My name is Michael Bargury. I'm the CTO and co-founder at Zenity. I do a bunch of work in the community, OWASP AI VSS, citizen development top 10. I give several public talks at Black Hat, at DEF CON, and trying to just figure out the space of AI and the unique attack surface that it introduces. And my number one goal as a brewer is to hire great folks. So reach out to me if you're interested. I want to start with just being honest about where we are. I don't think we are making we're making good progress in security from AI. And I actually think we are kind of living in a world in a bifurcated world. Ever increasingly, we're living in a bifurcated world. On one end, we are seeing benchmarks go up. And specifically, you can see the dates here. This is 2 years ago, where the big labs were basically saying, hey, we're going to fix prompt injection. We have 99% accuracy in finding prompt injection. Anthropic has very, very deep capabilities that they're publicly using to see into the model's brains, to wire lie detectors into the model's brains. With all of that power, it seems from the research community that we got a good handle on this problem, right? Well, no, on the other side, on the attacker side, attackers are very much partying like it's 999. Every system is hackable. These are just 4 examples of hacks that we showed at Black Hat last year. So 0-click attacks, no user in the loop, nothing for the human to do. We get in, we grab whatever we want and we go. Or we persistent long term, and we are not the only ones. There are plenty of examples in the last year where we basically see that every AI application is exploitable. And that is really where we are today. The applications or regular applications, software applications, they have to have a bug. That bug needs to be exploitable and reachable in order for it to become a real vulnerability that you care about. For AI agents, they are always vulnerable because by definition, if they are useful, then they are also useful for the attacker. And they can be manipulated to pursue the attacker's goal. So we are living in this weird world where 2 of these things are happening at the same time. The researchers, the labs, the science folks will say, hey, we got this sorted out. But from the hacker's perspective, that's not really where we are. So I want to take a step back and kind of figure out, why are we here? Why is this our reality? And on one big class of problems that I believe we have is that AI is simply weird. It's different than what we have seen so far, than what we try to secure so far. So, for example, it's non-deterministic. If an exploit or a payload works 1% of the time, is it still a vulnerability? Is it still a valid payload? Is it still an exploit? We don't know. AI is opinionated with somebody else's opinion. And this especially matters if you're not an American or a Chinese company. But for all of us, AI is generated by, a handful of folks, right? Handful of companies. And they get embedded with their own opinions, not by, I'm not claiming anything malicious here, but it's just part of the process. AI makes everything easier now. We used to talk about citizen developers. Now everybody's a vibe coder. Everybody's building whatever they want. And so, or a lot more than what they could earlier. And so it just changes, the economics of everything. AI is black box. Even the people that built it don't understand it. And this is something that is weird for us to figure out. AI, unlike software, lies with confidence. So when software fails, it usually doesn't lie to you that it was successful, but AI does. And it's gullible. It can be convinced to do malicious things, and pretty simply it can be convinced to do that. So all of this is true. But next to that, category of problems, which is the fact that just AI is super strange, super weird, there is also another category of problems that we are trying to figure out, that we are handling. And that is the fact that we're simply in a gold rush. I mean, everybody's rushing to get the latest AI deployed to the core of their enterprise right now, and that is getting truer by the day. And so what do I mean by a gold rush or gold rush problems? Well, there is confusion about what is the risk. Everybody has their own opinion. Every vendor will tell you agent security is their problem to solve, and therefore the narrative shifts, the way that you think about it shifts. Then there is this notion, especially with the labs and everybody that's kind of pushing AI to move fast, break things, change things, even inside of organizations, right? People, I've heard multiple occasions where executives come in with a mandate saying, "Hey, we got to use this technology right now, and nothing can stop it." So there's a pressure to lower the security bar to say, "Okay, we accept the risk. We need to move forward." There's also this herd mentality where if we think it's working for someone, maybe one of our competitors, then we rush to adopt it as well, and that can very much lead us astray. We kind of grow to accept the fact that these are black boxes, and we are learning to just flow with it. So an example is that the APIs that allow you to consume models, sometimes they change underneath your feet. They change the model, they change how much runtime compute the model gets. And we're still somewhat weirdly fine with that at the moment. And of course, when you move fast, there are costly mistakes. And so these are all gold rush problems, and we've been through gold rush problems. We know how to fix them. Of course, we have a solution for that, and we're going to apply it here as well. And the solution is, of course, to just not do anything about it because we don't have time to adopt AI right now. No, so I'm kidding. The actual solution is we fix it with AI, right? We slap AI right on top of that. AI is going to solve it. Mythos is going to solve it. No, don't worry about it. So here's our solution. In most cases, we will use these guardrails, trainings, safety training, safety classifiers that will go out and say something like, "Oh, AI is not supposed to do that. This is not an approved use case. I don't approve this doing that." So the problem with that is that it simply doesn't work because guardrails are not a security boundary. Guardrails are a content moderation technique. Guardrails help kind of create friction around certain types of conversation. Not enough friction for an adversary that really wants to use the model or your app to do the right thing. And so I want to kind of try to understand why. When you look at an injection, at a prompt injection attack, and this is just one of the payloads we showed at Black Hat, you can see that there are different parts of this attack that cover things like, hey, there's some social engineering involved, there's prompt engineering, there's evasion techniques, there's a bunch of different techniques here. But if you look at all of this, injection is really not the right term for what we are saying here. Injection is a very technical term, and it leads to thinking about a very technical solution. But actually, what is going on here is that LLMs are basically, whatever they have in their context, it's already there. They are shackled to it. And then they just output the next thing. And the next thing is a corollary to everything that came before. So if attackers can control the context, they can manipulate it in a way that the LLM will say whatever they want. And that is very similar to the movie Inception, where what they are trying to do, and if you remember that's a long time ago now, but if you remember that movie, what they're trying to do is implant an idea in somebody's head. And the way that they do that is that they paint the picture of the entire context of the concept they're thinking about, and they will bring in their subject, their victim, into that world, and they will fill it with their secrets, they will fill it with their desires. And so this is kind of what we're doing with AI. And so I encourage us to try and think about prompt injection, not as a vulnerability that we can fix or ever patch, but actually as a problem that we need to manage. And there's already something like that, which we've been dealing with for years, which is malware. Nobody's thinking that malware is a problem that will go away. It's a problem we need to manage. And so even just like as an example, even the people that are like the best at building guardrails, the models, the labs themselves, they fail, right? So it doesn't really prevent adversaries from using their services, and Anthropic's reports on threat intelligence reports show that clearly. And kudos for them for sharing them. So AI guardrails are soft boundaries. They won't help you. They won't help you really kind of protect your app. But hard boundaries do exist. Hard boundaries are basically the architecture of your system, the software around it, the place where you need actual real software bugs in order to circumvent them. And so for the remainder of the talk, what I would like to do is share with you our learnings that are kind of the led us to all of the zero clicks that we were able to present at Black Hat last year. Before you do that, before you have a working payload, you need to do reverse engineering. You need to understand how the systems are built. And some of these systems, some of these vendors put in place these mechanisms, some of them by mistake and some of them by design, that actually prevented us from doing meaningful impact. And so these are the things that I want us to look at today. So let's start with something simple, supply chain, just like the easiest example, right? So you want to build a customer success agent or customer support agent. How will you do that? Well, of course, you'll take the agent, you'll plug it into a bunch of different AI services, and now it's support services, and now it's a customer support agent, right? How do you do that? Well, of course, with MCP. MCP is the latest thing, so let's connect it. Of course, now there's also skills, but well, let's focus on MCP here for a moment. So MCP gives our agent access to everything, and now the agent is able to, the kind of general purpose agent becomes a customer support agent. The problem is that now MCP is part of your supply chain, and supply chain, of course, is very difficult. Just ask anybody that has done anything meaningful with sharing open source software. The thing about AI supply chain is that it unfortunately makes everything worse. So in the MCP ecosystem, we are seeing malicious MCPs, everything from the MCPs that are installing malware. That's kind of a typical NPM supply chain attack, to things that are a bit more sophisticated, like using the fact that MCPs are injecting these tool descriptions to push in prompt injections, a prompt injection technique. The problem with the MCP ecosystem is that actually it's worse than what we've had, and it's not like what we have works. So MCPs, first, they are a rug pull mechanism basically by design. They allow at runtime, your agent will go out to the MCP server and ask for the latest tool descriptions and the latest list of tools and resources. So that means that your agent now changes at runtime because somebody else that owns the MCP server says that, well, it's time to upgrade right now. MCP at least has package locks, you can have versioning, there are integrity checks, none of that exists here. A2A, of course, has the exact same thing, so don't think that will save you. And actually, one thing to note there is that this is everything that I just showed is actually not like it's by design. Why is it by design? Because MCP was designed not to turn your customer support agent into something useful. It was designed to take a general purpose LLM and turn it into a customer support agent or anything else, right? Because it was designed to be connected to the enterprise AI, to the AI assistants, the general purpose AI assistants. So what that means is that it uses prompt injection by design to inject the context into the AI to, at runtime, understand what it is right now. So this is what this mechanism should do. And everything that bred from that in the AI supply chain ecosystem is actually repeating that same fundamental choice. So skills are the same thing. Instructions files are the same thing. They are runtime injected, and they change your agent at runtime. So no matter what you do at build time, at runtime your agent changes. And that's a big change. Because with software, you could go to, hey, let's have a secure version of NPM, and let's create like an allow list of every third party. Here it doesn't really work because all of them can just change anything underneath your feet. Of course, we have a solution for that. We just fix it with AI, right? What do I mean by that? Well, people will take an LLM and will plug it on top of the MCP and say, oh, does it have any bad instructions? Of course, that's very easy to circumvent, right? Because that LLM has the exact same attack surface as the LLM that you're trying to secure. And so you'll just prompt inject your way through that as well. But hard boundaries do work. So if you do version pinning on a remote server, that would prevent rug pull attacks. If you require approvals for any upgrades to tools and resources, these are elementary things in supply chain. Okay, let's move to another example, AI browsers. So AI browsers are kind of have been one of the crazy things that we've seen pushed out throughout the last year. And you can see that when AI browsers started, or where computer use started, which was around the same time, or again about 2 years ago, if I'm correct, in terms of like when labs were starting to push it out. The first lab to push it out was Anthropic as a demo, computer use demo. And you can see the reason they put it out as a demo is that it poses unique risks, and we need to be very, very careful. So of course, putting it in a browser is absolutely fine, right? Computer use is dangerous, but putting it just in the browser that you're working with is absolutely okay, right? So of course, right after this was out, the folks at Brave, right after those browsers started becoming a thing, and the folks at Brave showed the first prompt injection attack to cause harm through a Reddit post. So your AI browser interacts with the wrong Reddit post, and it gets your browser to take over your account at Perplexity in this case, and send over the credentials to the kind of restore initial credentials to the attacker. We showed the same kind of attack on Perplexity just a couple months ago with Unprompted, and essentially what we did there was if your browser interacts with a specific Twitter message, just like a Twitter thread, it will go out without asking you, log into your 1Password account, initiate the account recovery, and then send the recovery keys to the attacker. So general, like full takeover of your 1Password account because you read the wrong tweet. And so, of course, the problem here that like anybody that's been in the kind of enterprise browsers or browser security or web security space would immediately say is, why does something that operates on Reddit or on Twitter, why can it change anything on the Perplexity side or on the 1Password side? We have cause for that, right? So we have a bunch of security mechanisms within browsers that are supposed to limit the impact that malicious content on one site has on another site. But all of those are out the window. So when agentic browsers were introduced, they intentionally had to remove barriers from the AI to be useful. And so they have kind of picked away all of the security mechanisms that were built there by years and years and years of security work. Of course, we can fix that with AI as well, right? We can have another AI look at the browser and say, oh, is there any prompt injection in here? But we know that solution is not going to work. What does work? Well, strong security mechanisms do work, right? For example, respecting cores. And one of the, and again, kudos to the Brave team here that essentially nerfed their own AI agent in their browser to keep it more secure. So now I want to move to just show some result of our reverse engineering on specific systems and see kind of the cool designs that people came up with to mitigate chunks of the prompt injection attack surface. So here's one example with ChatGPT. Back at 2024, Johan Rieberger showed the first memory persistence attack on ChatGPT, and he used basically he pasted his own malicious URL. It embedded the prompt injection into ChatGPT's memory, and that allowed him to take over future sessions, not just the existing session that was compromised. At Black Hat this year, we showed the exact same thing, but now we've been able to do that in a zero-click attack without the user having to paste any kind of into any malicious content into their field. We just were able to get in just by sharing a Google Calendar, Google Doc with our victim. And so let's see how this works. Memory in ChatGPT is controlled by an internal tool called the bio tool. And that's what allows ChatGPT to store memories. The bio tool is something, it is, again, the most important piece for persistence attacks, because if you can implant a malicious memory into ChatGPT, you now can change ChatGPT's behavior on the long term. You're no longer talking to ChatGPT, you're talking to a bad version of ChatGPT controlled by the attacker. So the thing is that when we started to test this, we found that once untrusted data enters the context, anything from the connectors, and then when you ask, and if you ask later ChatGPT to store a memory, it says it can't. And when you kind of force it to reveal the message, the internal message that it got, it says the message that it gets, it actually tries to invoke the bio tool, but it fails. So this is not the AI refusing to use the bio tool. This is ChatGPT behind the scenes completely shutting down the bio tool. It's not out of the context, it's still there. AI can still invoke it, but it will result in a failure. And this is actually a very cool mechanism by OpenAI. Whenever untrusted data enters the context, they shut down the ability to store memories. And so in the talk, we were able to circumvent this control, but circumventing this control didn't just mean, oh, we tried to get the AI to kind of to persuade the AI to go around guardrails. No, we just had to find a bug in the software mechanism that exists here. And so this is a very cool hard boundary, and I recommend others to use something similar. Another boundary that I think is good is that whenever untrusted data enters the context for ChatGPT, you can see this is a result of a reverse engineering of our reverse engineering of ChatGPT and the response that it gets from the search tool that it has. And you can see that the piece where it simply provides the user the content that it finds in that third-party system, it enumerates each one of the line. It prefixes each one of the lines with a numerical, with line numbering. And the reason why this is cool is because it prevents line jumps. And so it is a strong primer to the AI that this is untrusted data. Of course, this is not a full hard boundary, but it is very useful. Let's go to another example. So a couple of years ago, we showed an attack on, a lot of different attacks on Microsoft's Copilot Studio. And one of the biggest problems that existed there is that Copilot Studio was logging in as the maker's identity. So it embedded the maker's identity within that agent. And because SharePoint, once you connect to SharePoint, you can connect with the same token to every SharePoint, then even if this bot was intended to use only one SharePoint site, we could convince it to get to another SharePoint site. So if you just exposed, I don't know, the public docs for the entire company through a bot, I could abuse your agent to actually get access to a private SharePoint you only had access to. So the mitigation by Microsoft to this is just to remove AI's ability to use any SharePoint site possible. So a human, the builder, must be the one to choose which SharePoint site his agent has access to, which again is a very good mechanism to basically say, don't give AI too much agency. Don't give it access to something that it doesn't need access to. Here's another example, again from our Copilot work. One of the ways that we found into an organization is to basically share just a Teams message from another tenant. So we just send a Teams message to you. And because Copilot reads every Teams message that you get, this is a way to do prompt injection, to infiltrate into your organization, into your Copilot and hijack your Copilot. So the mitigation by Microsoft here is to say, Copilot can still read your Teams messages, but for external folks, you need to accept the message first. Like a human has to say, this is a trusted person, and only then Copilot can read their messages. Before, it simply does not have access to that messages. So this is, again, a very cool mechanism that would allow people to, sorry, I'll re-say that. So this is, again, a very cool mechanism to prevent external attackers from having a clear attack surface into your organization. All right, so for the last example, I want to take an easy example. Let's talk about image rendering. Image rendering is probably the biggest way, the most common exfiltration vector from an AI agent or an AI assistant. And that basically means you grab the information you want, you put it into a parameter in an image, and then you get the AI to generate that image. And once it generates the image, your data is out. And so there are many different attacks that show that this is like repeated again and again and again and again and again. And why is this the case? Well, because people are essentially trying to take the output of an AI, the output of HTML or Markdown rendering, and then use a bunch of pattern matching to find all of the ways where people will render an image, and filter them out. But why? Like, why are we taking a library that can render any link and then retroactively removing the ability to render links from it? Why not ship a markdown renderer that simply has no ability to render images, or simply has no ability to render images outside of our specific domain list, trusted domain list? And there are actual attempts at this. One of them by Vercel. I recommend you checking their project. And so I'll finish with one more thought. How many of your agents that you have, like, think of the agents that you currently have out in production, how many of them need the ability to write general purpose software and then execute it at runtime without anybody in the loop, without anything happening? The thing is that all of your agents have that capability. That is the React loop. Like, the React loop is writing software and executing that software at runtime. It's just a weird kind of software, but that's always the case. So do we really need to do that again and again and again? I'm not sure. Like, how many of our AI agents can generate automations that might replace them in some of their capabilities, some of their runs? Not everything, but we don't really need to spend and respend those tokens each and every time. And so I'll finish off with one thought. Back in 2024, I had this slide in my Copilot talk saying that basically we don't know anything, and all of us are noobs here. There are no experts, and we need to figure this out together. And I'm happy to say that now I think we know some things. There are still many things we don't know, but we do know some things. And so here's a list of problems, some of the hard boundaries. Some of them we covered here, some of them we didn't. I really encourage you to look at them and try to see if they work in your scenarios. And so as a recap, we have two types of problems and we need to treat them differently. The AI gold rush is going to lead us to, we've known gold rushes before, but we need to control the risk, and here the pace is just phenomenal. It's just crazy. And the AI's weird side, that is different. And for that, we need different kinds of mechanisms, and wishful security guardrails aren't enough. So we should take a moment to think about how far we've come from this slide. As this is a slide from IBM 1979. A computer can never be held accountable, therefore a computer must never make a management decision. Well, we are doing just that. We are working on getting AI to make business decisions on our behalf. And business decisions, of course, mean taking on risk. And that means we need AI we can trust. And wishful thinking or asking it nicely is not the same as knowing that it's not going to wreak havoc where it shouldn't. And so with that, thank you very much. Have a great day.